Hey guys, this is Leetcode problem number 334 and it's called increasing triplet subsequence, and it reads that given an integer array nums, return true if there exists a triple of indices I, j, k such that I less than j, j less than k, and nums of I less than nums of j, nums of j less than nums of k. If no such indices exists, then return false. So basically there is an array given and we need to find out if we can construct a subsequence of three elements from the array where the elements from left to right of the subsequence are increasing, and the subsequence has to be strictly increasing. Like, it means that two adjacent elements, they cannot be even equal to one another. The value always has to be on the rise from the left to the right side. So suppose there's an array, I have an array of 6 elements, and I need to pick up a subsequence and to check whether there is a subsequence where the elements are strictly increasing from left to right in that subsequence. And there was a difference between subsequence and subarray. Like, a subarray is basically constructed of elements that are adjacent to one another in the original array, but subsequences are, it's not necessary that the elements of a subsequence are held adjacent in the original array. So that is the difference between a subsequence and a subarray. And the approach that I need to use is, like, suppose I'm checking an element that is 6 and I'm at 6. Suppose I'm at 6 at the moment, and I need to check to the left side and to the right side. And to the left side, I need to check whether there is any element that is smaller than 6, because elements get larger to the right side. So elements to the left is obviously going to be smaller in a strictly increasing subsequence. So I'm checking in the left side whether there is any element smaller than the current element, and it is the complete opposite to the right side. To the right, I'm going to check whether there is any element that is larger than 6. If these two conditions satisfy, then we have a subsequence. And that is what we need to check for the elements in the array. Now, I need to be traversing from right to left to find out, like, till a particular position, suppose this, till 9, what is the highest element from the very right side. Like, till 9, there are 2 elements, and the highest number till this 9 is 9 itself. And from right to left till this 3, the highest number still remains 9. And that is how we are going to traverse from right to left and check for the progression of the highest number till a particular index. And we are going to be storing those numbers in a vector, and a particular index of that vector is going to represent the highest value from the right side till that element, till the corresponding index, I mean. And that's how, when we finish traversing from right to left, we're going to traverse from left to right, and we're going to check for each element whether there is any element that is larger than that element to the right side. And the corresponding index of the vector that we have been storing the largest value from the right side to will tell us whether the current element is the highest element from the right side till that element. If that is not the case, that means suppose this 6, and till this 6, the highest element is 9. I have been traversing, right, from right to left. So the highest element is 9. So this means that, of course, 6 is smaller than 9. So there is a number that is greater than 9, sorry, greater than 6 to the right side of it. And if that satisfies, then we are going to be checking if it is the highest element, it is the smallest element from the left to right. Now, because I have been traversing the second time from left to right, I already know whether 6 is the smallest element from the very left, and which is not the case. And when these two conditions satisfy, I know that we have a desired subsequence. So just to recap, first what we gotta do is check from the right to left and see till each index what is the highest value till that index from the very right side. And we're going to be storing those values in a vector so that later on when we are traversing from left to right, we can check for a particular element if that element is the highest element till that element from the right side. And if that is the case, that means condition 1 is ticked, and then we check for condition 2, and that is if there is any element smaller than the current element. If there is any element smaller to the left of that element, and if these two conditions satisfy, that means that we got to return true. We got a desired subsequence. So I think it will be easier if I start coding and you guys can pick it up a bit better if you're not already clear. So as I was saying, we need to store the highest value of a particular index from the right side in a vector. So I'm gonna call that vector backward vector, since I'm traversing from right to left and picking up the values, and it will have nums.size elements, and initially let's just set the values up to 0, and we need a variable called maxNum, and that will be updating the highest element till a point when we are traversing from right to left. And initially we're going to set that to the rightmost element, that is nums.back, since there has to be an element or a value with which we can compare later on as we are traversing through. And then another variable that is min_num, and this is for second traversal. We are going to be updating the minimum value till certain points. And initially we're going to set that to, since we're traversing from left the second time, we're going to equal it to the first element. And now firstly we're going to traverse from right to left, starting with the last element, and till the first element. We're going to be checking the maximum number till the current index each time. So maxNum, and this actually is nums.size -1, sorry. So the initial index is nums.size -1. So maxNum equal to maxNum and nums of I. We're checking whether the current element is the highest we have found till now, okay? and the corresponding index in the vector, backward vector, would be equal to the current highest, and that is max num. We're going to do that till the last element. And now we're going to be traversing from the left side to the right, and we have to start from index of 1 because there is no element to the left of index 0, and we have to end at the second last index because there's no element to the right of the last index. We're basically considering each index as the middle element if there is any desired subsequence. And we're checking for the mean num. Checking if the current element is smaller than mean num, then mean num will be updated. And if nums of I is greater than mean num and backward vector is, what is it gonna be? It's larger than nums of I. That means there is an element that is larger than nums of I, meaning there is an element larger in the right side, since we traversed from the right side to the left to get the values of backward vector. If that is the case, then return true. And if there is a desired subsequence, then we would find it out inside the loop. And if there is no desired subsequence, that means there isn't a subsequence that we desire, and we're going to return false. Oops. Just run the code. Alright, so that's how you can solve this. And I'll see you guys in the next video, and you guys take care till then.